really common troubleshooting approach we use when we have a device like an end-user PC that cannot get to some destination out on the network is to follow the path. And as we're following the path during our troubleshooting, the first step along that path is often a wiring closet switch to which that end device is connected. What we might want to do is go to that switch and verify that the client's MAC address has been learned on the appropriate port on that switch. Let's see how we can take a look at the contents of a switch's MAC address table. We can do a show MAC address table, and notice that we've got several static entries and a few dynamic entries. Now, a static entry could be an entry that we made ourselves. We could have manually said, this MAC address is off of this port. However, you'll notice that all of these ports say CPU. These are MAC addresses associated with the switch's processor. It looks like we've not statically entered any MAC address mappings, but we have dynamically learned a few. It looks like off of Fast Ethernet 1/0/1, we've got this MAC address. And based on our topology, that should be the PC's MAC address. And we could go to that PC and verify that, yes, that is the MAC address of the PC. It's being learned off of this port. But what might prevent this from happening? Well, if we don't have connectivity into the switch port from the client, that could prevent the switch from learning the client's MAC address. Or maybe the MAC address table is full on that Cisco Catalyst switch. Different switches have different capacities to store MAC addresses. Maybe this is because we have just a really, really large network with thousands and thousands of MAC addresses, but it could be because of a security issue. Sometimes an attacker will send just a flood of frames into a switch, with each of those frames claiming to be from a different MAC address, and that can fairly quickly fill up a switch's MAC address table. And if that table fills to capacity, what happens when we add a new device to the switch? There's no room to learn the MAC address of that new device. So what happens when a frame comes in destined for that device? Well, since the switch has not learned off of which port that MAC address lives, to make sure it gets to the right place, the switch is going to flood that frame. In other words, it's going to send a copy of that frame out of all other switch ports other than the port on which the frame was received. And that might allow the attacker to start capturing. They could start sniffing the packets coming off of a different port. And by the way, we could combat that type of attack using port security, which is a topic we talked about back in the Switch Complete video course. But if the MAC address table is filling up not because of an attack, but because we just have a really, really large network, we've got lots of switches that are interconnected, to help prevent that MAC address table from filling to capacity, what we could do is make sure that if we haven't heard from one of those devices with one of those MAC addresses for a certain period of time, we can age them out. We can remove them from the MAC address table. And if they start speaking again, we can simply relearn their MAC address, but no need to keeping MAC addresses for hours or days or weeks possibly. What we can do is time out MAC address entries, again, if we've not heard from that MAC address for a while. Here's a command we could issue to see how quickly we're aging out those entries. We could say show MAC address-table aging time. And it looks like on this Cisco Catalyst switch, the aging time is 300 seconds. I'm aging out MAC address entries every 5 minutes if I've not heard from those MAC addresses within the last 5 minutes. And while a layer 2 switch makes forwarding decisions based on MAC addresses, many of our switches are multi-layer switches. They can make forwarding decisions based on other criteria, such as destination IP addresses, such as quality of service access control entries, or QoS ACEs. We might have security ACEs, security access control entries, which make up a security ACL, an access control list. And many of our switches have a TCAM, or ternary content addressable memory, that can help a switch make a forwarding decision based on criteria like that very, very rapidly. The TCAM can help a switch very efficiently make a forwarding decision because it combines quality of service entries, security access control lists, and IP version 4 route information into an area of memory that can be queried when the switch wants to make a forwarding decision. And notice I said IP version 4. There is a way for the TCAM to support IP version 6 routing, but it might not be enabled by default on your Cisco Catalyst switch. It's not enabled by default on this switch. I'm running a Cisco Catalyst 3750 series switch, but depending on what we want our switch to do we want it to do IPv4 and IPv6 routing? Do we want it to keep track of lots of routes Do we want it to support multiple routed interfaces, or would we rather it just learn lots and lots of MAC addresses? We've got a finite amount of resources in our TCAM, and we can reallocate those resources depending on what we want the switch to do. Where is it going to be playing a role in our network? Well, the great news is we've got some flexibility in how we allocate those resources. We can apply an SDM template. SDM, that stands for Switch Database Management. And this template can tell the TCAM how to allocate its resources. For example, let's say we had a switch that needed to keep track of lots of VLANs and lots of MAC addresses, but it didn't need to do much, if any, routing. Well, we would probably want the TCAM configured differently than a switch that we might have at the distribution layer or the core layer, where we might need to keep track of lots of IP routes. To see what SDM template we're running right now, we can give this command. We can say show SDM prefer. And right now it says we're running desktop default. That's the SDM template we're running, and that's the default on this switch. And notice it supports 8 routed interfaces, it supports 1024 VLANs, and it supports a certain number of quality of service entries, a certain number of security access control entries, a certain number of IP version 4 unicast routes. Notice that this output doesn't say anything about IP version 6. But there is a way, and I'm going to demonstrate it for you, to support IP version 6 routing on this Cisco Catalyst switch. In fact, let's take a look at the command that lets us select an SDM template to use. Let's go into global configuration mode, and I'll say SDM prefer. And let's give some context-sensitive help. We've got 5 options here: access default, dual IPv4 and IPv6, routing, and VLAN. Let's talk about each of these, beginning with access. The access SDM template might be appropriate for an access layer switch, where we know about lots of VLANs, but we're not doing much routing. Default is what we have by default, and it gives us a mixture of support for some routing and the ability to know about several VLANs. Dual IPv4 and IPv6 is going to add IP version 6 routing support, and this is the SDM template we're going to apply in just a moment. Next on our list is routing. Now, routing might be appropriate for a distribution layer switch, a core layer switch, where we need to keep track of multiple routes. But keep in mind, if you just say routing by itself, that's only giving you IP version 4 support. You're not routing IPv6 traffic if you select that SDM template. And the last one on the list is VLAN. If we have lots of VLANs and those VLANs contain lots of devices, we might need to go with this template in order to store all of those MAC addresses. Now, let's say that we've got a trouble ticket that's indicating that this multi-layer switch is unable to route IP version 6 traffic. We might begin by saying, what is the SDM template applied right now? And does it give us IP version 6 support? Let's go back out to global configuration mode and recall the command we gave. We can say show SDM prefer. And right now we're using desktop default. No indication of IPv6 anywhere. I just see a bunch of IPv4. But we can change that. Let's go into global configuration mode and we'll say SDM prefer. And with context-sensitive help, we're going to select dual IPv4 and IPv6. Let's select that, but we're not done yet. If I give some more context-sensitive help, we can see that we can add IP version 6 support. We can have a dual stack, in other words, and we can still influence if we want to give a bias toward this switch doing lots of routing or keeping track of lots of VLANs and lots of MAC addresses, or if we want sort of a mixture. We could go with default, which is going to give us 8 routed interfaces and 1024 VLANs. If we want to keep track of lots of routes and we want to have more routed interfaces, we could say routing, and because we're saying it after giving this option, we are going to be able to route for IP version 6. Or if we have lots of VLANs and lots of MAC addresses and we want to allocate the TCAM resources to keep up with all of that, we could say VLAN. I'm going to say default. I'll just get a mixture, but I'm adding dual stack support. Now, when I do this, it doesn't take effect immediately. Let me prove that. If I do a show SDM prefer right now, you'll see that it still says desktop default. If I try to configure IPv6 unicast routing, it will not let me. Check this out. If I say IPv6 unicast doesn't seem to work, let's give context-sensitive help. It doesn't even know about the IPv6 command because this change that I made doesn't take effect until we reload. It says on the next reload, the template is going to be installed. So let's do that. Let's reload the switch, and I'll pause the video so you don't have to wait through a switch reboot, and we'll be back in just a moment to see if we have IPv6 support. All right, the switch has been rebooted. Let's see what our SDM template is now. Let's again give the command show SDM prefer. This time it says desktop IPv4 and IPv6 default. Now we see references to IPv6 in this output. Let's see if we can now enable IPv6 unicast routing, a command that wasn't even recognized a few moments ago. Let's go into global configuration mode and say IPv6 unicast routing. There it is. We now have IP version 6 routing support by changing the SDM template. And that's one of the most common reasons we would change the SDM template. Another reason we might change this template is we're running out of a specific resource and we want to reallocate the TCAM resources. To see the current usage of the TCAM resources, we can give this command. We can say show platform TCAM utilization. And notice that we have a column for the maximum number of values that the TCAM can accommodate for things like IPv4 quality of service ACEs, IPv4 security ACEs. For example, it looks like I can support a maximum of 768 quality of service access control entries. And I'm currently using 260 of those 768 available entries. If numbers in the used column are approaching the maximum values, that might be of concern to us. One of the things I would encourage you to do first before just changing the SDM template is to see if you can be more efficient in your configuration. For example, if you're running out of entries for IPv4 unicast indirectly connected routes, instead of changing the SDM template with a bias toward routing, what if you did route summarization? That could cut down on the number of route entries you had. Think about ways to optimize your current configuration before changing the SDM template, because after all, this is a zero-sum game. We've got a finite amount of TCAM resources, and it's really important that we use them wisely. Well, that's a look at how we can start following the path, verifying that a MAC address exists in a switch's MAC address table. And if that switch happens to be a multi-layer switch, we took a look at the different TCAM resources that are available and how we can reallocate those resources based on what that switch needs to do for us.